Math is a wonderful thing.
Hi, today Kieran and I are going to teach you about integration by partial fractions. And this is a concept that usually occurs on the no calculator multiple choice portion of the AP exam. You can know that you need to do integration by partial fractions if the denominator is higher, it has a higher power than that of the numerator. And if it doesn't, you should look to do synthetic division. Also, if the answer choices include multiple natural log terms getting added or subtracted to each other, you know that you probably should be using integration by partial fractions. Now, two things to remember before we get started. The antiderivative of 1 over x is 1 times the natural log of the absolute value of x, and also always add c when you're integrating.
Okay, so this is the term that we're given, and we know that since the denominator has a higher power than the numerator, that we're going to use integration by partial fractions. And also, if this is on the multiple choice section of your AP, then you know if the answer choices have natural log in them that you're going to have to use integration by partial fractions. So here we already have the denominator factored, and if you factor it one term further, this is what you're given. So you set this fully factored term equal to different variables after you decompose the denominator. So you take the first term and you put it on the bottom, the second term, put it on the bottom, third term, and you put it on the bottom, and you pick whichever variables you want to set equal to. So you can solve for these, and you know how, by the methods you already know, how to integrate this term. So if you multiply the denominator by the right-hand side, you get 2 equals a times these two terms because the 3x drops out, and each term has one term that is dropped out. And once you get to this part, you have to solve for different things. You have to solve different x's that'll drop out one or two of the variables so you can solve for one variable. So at this point, you want to get one or more terms to drop out so you can solve for the letters. So logically, you want to start with 0 because you have two terms that when multiplied by 0, they would cancel out the entire term. So if we plug in x equals 0, you get 2 equals a times 1 equals b plus b times 0 plus c times 0. So since these two terms cancel out, you get 2 equals a. So now you have your first term. Now you can also do x equals 1/2 because right here 1 minus 1 equals 0. So if you do that, you get 2 equals a times 0 plus b times 3 over 2 times 2 plus c times 0. So now that these two terms cancel out, you get b equals 2/3. Now for your third term, you want to get c by itself. So to do that, you do x equals negative 1/2. Then 2 equals a times 0 plus b times 0 plus c times negative 3 over 2 times 2. After this, you can do 2 equals c times negative 3, and then c equals negative 2/3. Now that you have all three of your variables, you can plug it into the equation that we created earlier. So you have a over 3x plus b over 1 minus 2x plus c over 1 plus 2x. And once you can take the integral of this using methods you already know. And you have to remember that 1 over x equals the natural log of the absolute value of x. But before that, we can simplify this by taking out 2/3 from each term and multiply the integral of whatever is left over. So you get 1 over x plus 1 over 1 minus 2x minus 1 over 1 plus 2x. So once you have this, you just take the integral of it. So it's 2/3 times the natural log of the absolute value of x plus the natural log of 1 minus 2x minus the natural log of 1 plus 2x plus c. And these are all in absolute values because you can't have a positive when you're doing a natural log of something. So from here, if you want, you have to remember that when you add natural logs, you're multiplying what's inside And when you subtract natural logs, you divide what's inside. So that would be the natural log of x times 1 minus 2x divided by 1 plus 2x. And that would all be the absolute value times 2/3 plus c. So but this would be the answer given to you on your AP exam.
All partial fraction problems will not be as easy as the one we just reviewed. Some will contain repeated terms or a second-degree exponent in the denominator. This is a useful chart with examples of how to handle these scenarios. When performing partial fraction decomposition, you write new fractions with each of the terms from the factor denominator, assigning variables for the unknown numerators. The variables are capital letters, and the numerator should be 1 degree lower than the denominator. The first example is similar to the problem that we just reviewed, as it contains a first-degree factor. The numerator, therefore, is a constant. In the second example, the term ax plus b occurs 3 times in the denominator. You will account for that by forming 3 fractions containing increasing powers of this factor in the denominator. If ax plus b were raised to the 4th, you would add d over ax plus b to the 4th. If the denominator contains a second-degree factor, the numerator will need a first-degree factor instead of just a number. This is the case for the third example, as it contains an ax squared as well as a bx. Because it has an x squared and an x, the numerator will need an ax and a constant b. Finally, the fourth example contains both a repeated term as well as a second-degree factor in the denominator. Integration made easy. A, B, and C for factors 1, 2, and 3. Higher power on the bottom, factor to solve your problem. Make these factors disappear, place them under A, B, C, and so forth from here. Plug in x values to solve for these letters, and Mr. Olivo will think you are clever. Rewrite your integral in multiple parts, integrate normally using your smarts.